Okay, we're talking about Unit 6, Section 2, Day 3 today. We have sort of one more type of function to go over. It's called a step function. A step function is a piecewise function containing all constant horizontal pieces. A step function is discontinuous with abrupt changes within different intervals, and the abrupt changes in the function's value result in a graph that resembles stair steps. So, this is I think pretty simple, but I guess y'all will be the judges of that. So we have this piecewise function here where there's 5 pieces, so we have 5 domains, but the equations inside this function are just constants. So 1, 2, 3, 4, and 5. So from 0 to 1, our function is just the value of 1. So from 0 to 1, we're just going to have the value of 1, which means it's going to be the straight horizontal line. And 0 is less than or equal, so it's going to be a closed interval at the x value of 0, and then an open circle at 1. And it's just going to be a straight line that goes from 0 to 1, and it's the y value of 1. So this is just a straight horizontal line. Remember, if you have a constant, that's just a horizontal line at that y value. And then from 1 to 2, it does the same thing, only our horizontal sort of y value is 2. So from 1 to 2, it's going to be closed circle. We're going to 2. That's going to be open because it's just less than. And it's going to be a straight line for the y value 2. And if I keep doing this, so 3, 4, and 5, it just sort of follows the same pattern. And that's our step function. Remember, the graph should have an open dot at endpoints not included in the interval, which is what we did, and closed dots at endpoints included in the interval. So 2, 2 should be an open dot, but 2, 3 should be a closed dot, which is what we have. 2 closed dots for the same x value would result in a graph that is no longer a function. Okay, so specifically, we're going to look at a couple specific types of step functions today. Floor and ceiling functions, and they have sort of weird notation for this. A floor function is represented by these little bars with like a little, sort of like these little legs at the bottom. And what this means is our x value is mapped to the greatest integer less than or equal to x. So basically, you just round down to the nearest integer. We're going to do some examples in a minute. And then we have a ceiling function, where it's sort of the same bracket, only the legs are up top. And x is mapped to the least integer greater than or equal to x. So I don't want to make this harder than it needs to be. Let me show you all these examples. So let's say we do the floor function for 2.3. You just go to if it's floor, you go to the closest integer below that number. So the closest integer below 2.3 is 2. If it's a ceiling function, you go to the closest integer greater than that number. So 2.3 is going to go to 3. That's the greatest integer, or that's the closest integer greater than that number. So before we get to these negatives, because they can be a little confusing, I want to throw in a couple more examples. Let's say we had 4.999 for a floor function. Well, even though that number is really, really, really close to 5, when it's a floor function, you go to the closest integer below that number. So even though this is really close to 5, we're still going to go to 4 here. Likewise, let's say we had a ceiling function of 5.001. Even though 5.001 is really close to 5, if we're going to the closest integer greater than this number, then that answer is going to be 6. Now, when it's negative, you got to think carefully, all right? If we're doing a floor function for negative 4.7, what is the lowest integer? Like, what is sort of the integer less than this number that's, closest to this number? It's not negative 4. It's negative 5. So just be careful with that. Negative 4.7, that's between negative 4 and negative 5. Negative 5 is the number that's less than negative 4.7. So negative 3.1 if we're doing a floor function. So negative 3.1 is between negative 3 and negative 4. you're going to go to -3. -3 is the sort of the greater integer, like the greatest integer that's, greater than this number. The closest integer greater than this number. Sorry. All right, so we're going to graph the floor and the ceiling function and evaluate the following table as a floor function. So this is a floor function, and we're going to put in some values here. So -2, well, that's just going to be -2. That's already an integer, so you don't need to worry about sort of rounding down or rounding up. If it's already an integer, just leave it. If it's -2.01, okay, it's a floor function, so we want to go to the greatest integer less than this number, and that's going to be -3. And then -2.7 will be -3. And then -3 is also -3. So each time, we're just going to the greatest integer sort of less than that number. And let's see here, -3.5, that's going to go to -4. And -3.99, that's going to go to -4 as well. So basically, when you're doing the floor function, you're thinking about sort of what are the integers that this number is between. And if it's floor, you want to go to the less of those two integers. All right, for the ceiling function, same values. If we're doing -2, well, that's already an integer, so we're just going to leave it -2. If it's -2.01, if we're going to sort of the integer that's greater than that number, like the least greater integer, that's still going to be -2. So -2.01 is between -2 and -3, and we want to go to the greater of those two integers. -2.7, also -2. -3 is going to be -3, and then -3.5 and -3.99. Again, both those numbers are between -3 and -4. If it's a ceiling function, we want to go to the greater of those two integers, so it'll be -3, -3. Okay, so it wants us to graph the floor function and the ceiling function from -2 to 4, so we're going to go a little out. We're not really using these values over here that we just put in, so I guess we're going to sort of just think about this from scratch. So at -2, well, -2 is definitely included. So if I were to plug in -2, we would just get out -2. And then if we were to do -1.5, so -1.5, if we're doing a floor function, we want to go to the integer less than that. So between -2 and -1, like -1.5, -1.7, -1.1, all of those values are going to be on -2. And then when we get to -1, we're going to have an open circle here. And the reason why is at -1, that is just an integer, and at -1 we have a value right here at -1. So it sort of steps up at -1.01. We would still round down to -2, so all those values are right here. But as soon as you reach -1, it jumps up, and -1 is just -1. And then everything between -1 and 0, like -0.5, -0.8, -0.2, all of those values are going to be on -1 as well. We'll have an open circle once we get to 0, because at 0, that's an integer, and he's going to jump up. And this pattern is just going to keep continuing. And that is our graph of our floor function. So the ceiling function is going to work a little differently. At -2, well, -2, oh, it didn't want us to do, well, let's pretend it says less than or equal. So at -2, we sort of plug in, there's just a point here. But then everything between -2 and -1 is going to round up to -1. So I'm going to do a little open circle here at -2, -1, and have a straight line that goes all the way to -1. And it goes right there. And at -1, that's still at -1. And then after that, everything greater than -1, or everything between -1 and 0, is going to go to the integer of 0, because that's the greatest integer between -1 and 0. And then that pattern is going to keep repeating. Now, notice, we only graphed part of the ceiling function and floor function. Technically, these sort of go on forever in both directions. But this is the ceiling function, this is the floor function. Okay, there's a few more notes on the back. Or on the next page, there's 2 more examples. These are not floor or ceiling functions. It's just more practice sort of graphing piecewise functions where there's just steps, so it's still just sort of constants right here. So for x values less than -3, we have sort of this constant of 1. So less than -3, it's going to be open circle, and we're just going to have an arrow that sort of goes outward for 1. Between -3 and -1, we're going to be at the y value of 3, and it's going to be a closed circle at -3, and it's going to be an open circle at -1. It's going to look like that. And then for all x values greater than or equal to -1, so it's greater than or equal, we're going to have a closed circle. It's going to be at 4. That's our step function. For example 5, all x values between 0 and 2 are going to have a y value of 2, and this is closed for both 0 and 2. It's less than or equal, so 0 and 2, closed circle at 4, closed circle at the x value of 2, sorry, x value of 0, closed circle, x value of 2, closed circle, and we're going to have a straight horizontal line at the y value of 4. From 2 to 4, these are going to both be open circles, open, open, a straight line right there. And then from 4 to 6, closed circle at 4, and then open circle at 6. And that's all there. Oh man, I just realized y'all couldn't see what I was doing. Do I really want to redo this video? The answer is no, I don't. So I apologize. You could, hopefully you skipped ahead and hope that I fix this at some point, although I didn't fix it till the end. But these are relatively easy, but yeah, I don't know. I apologize. Not going to redo it. It is what it is. I'm going to do the homework now as well. So I'm going to wrap this into the same video. I'm just going to start working on this. You might want to pause and try the homework yourself before you watch. So let's see here. Make sure we're on the camera. We are. From -1 to 2, we're at 3 and closed, open. So -1, closed, open at 2. From 2 to 4, we're going to be at the y value of 5, and it's going to be closed and open. From 4 to 9, it's going to be 8, closed, opened. And then from 9 to 12, opened. All right, let's see here. So then number 2, so same deal. -4 to -2, it's going to be closed and open. So at -4, we're going to be at 6, and it's going to be closed. And at -2, we're going to be open. From -2 to 1, -2 will be closed. We're at the y value of 4. Going to 1. From 1 to 3, closed, open.